Equations containing a modulus can be solved by algebra or by using graphs. To solve such an equation by algebra, there are a number of properties of modulus that we need to investigate. So, if the modulus of x is equal to a, where a is greater than 0, then x is equal to a, or x is equal to minus a. For example, if the modulus of x is equal to 7, then either x is equal to 7 or x is equal to minus 7. This makes sense. The two numbers that are 7 units from the origin are 7 and minus 7. So let's have a look at an example. Solve the equation, the modulus of x plus 3 is equal to 2, by sketching a graph and then by algebra. Okay, well, the graph of y equals the modulus of x plus 3 is V-shaped and has its apex, or its corner, on the x-axis at minus 3. So here's our x-axis, and here is minus 3, and this is where the apex, or the corner, or the point of our V-shaped graph will be. To solve the equation, we can draw this graph and the line of y equals 2, because we were told that the modulus of x plus 3 is equal to 2. So that's why we draw a line at y equals 2. The solutions are the x-coordinates of the points of intersection of the graph and the line. So we want to start off by actually drawing the modulus itself, the modulus graph. So we were told that the modulus of x plus 3 is equal to 2. So what we want to do is move the modulus of x 3 steps to the left. So if we just had y equals the modulus of x, we would have our apex, or our V-shape, or the point of our V-shape, at the actual origin. So instead we're going to move it 1, 2, 3 places to the left. So we've moved our graph 3 places to the left. So then we're going to draw our line across y equals 2, and we're going to drop perpendiculars down to the x-axis at the points at which it touches our graph. So from the graph, the solutions are x equals minus 5 and x equals minus 1. So what we did was we took the modulus of x graph, which usually has an apex at 0, 0, and we moved it 3 places to the left. Then we drew in the line y equals 2, and the 2 points at which it crossed our graph, or touches our graph, we dropped perpendiculars down to the x-axis, and we found those 2 points to be minus 5 and minus 1. So part 2, we want to solve by algebra. So by property 1, so by Modulus Property 1, we have the modulus of x plus 3 is equal to 2. So we have x plus 3 is equal to 2, or x plus 3 is equal to minus 2. So x is going to be 2 minus 3, which is minus 1, or x is going to be minus 2 minus 3, which is minus 5. So again, we can see minus 5 and minus 1 are indeed our solutions. Modulus Property 2. If the modulus of x is equal to the modulus of y, then x is equal to y, or x is equal to minus y. If two numbers, x and y, have the same modulus, then they are the same distance from the origin. This can only be true if the two numbers are equal, or one is the negative of the other. For example, the modulus of 3 equals the modulus of 3, and the modulus of 3 equals the modulus of minus 3. Solve for x, which is an element of the real number set. The modulus of 2x minus 1 is equal to the modulus of x plus 2. So by property 2, the modulus of 2x minus 1 is equal to the modulus of x plus 2, becomes 2x minus 1 equal to x plus 2, or 2x minus 1 equal to minus times x plus 2. Make sure you use brackets here because the minus applies to both terms. So 2x minus 1 is equal to x plus 2, becomes 2x is equal to x plus 3, because minus 1 comes over the equal sign, becomes plus 1, and 2 plus 1 is 3. And then x comes over the equal sign, becomes minus x, so 2x minus x leaves us with x, so x is equal to 3. Or 2x minus 1 is equal to minus times x plus 2. Becomes 2x minus 1 is equal to minus x minus 2. So we have minus by x is minus x, and minus by 2 is minus 2. The minus x comes over the equal sign, becomes plus x, and 2x plus x is 3x. And the minus 1 comes over the equal sign and becomes plus 1, and minus 2 plus 1 is minus 1. Then we divide across by 3, so x is equal to minus a third. So to solve for x, we end up with x is equal to 3, or x is equal to minus a third. Modulus property 3. The modulus of x squared is equal to x squared, i.e., when we square a modulus, we can just remove the modulus. The reason for this is that when we square a number, positive or negative, the outcome will always be positive, because a plus by plus is a plus, and a minus by minus is a plus. So when we square something, no matter what it is, the outcome will always be positive. Thus, we no longer need the modulus symbol. Here's an example. Find the value of m, which is an element of the real number set, for which the modulus of m plus 1 is equal to the square root of m squared plus 5. Because of the square root on the right hand side, we will square both sides and remove the modulus. So we have the modulus of m plus 1 is equal to square root of m squared plus 5. We're going to start off by removing the modulus symbol and adding in the squared symbol and making sure that we've got brackets because it's m plus 1 squared, it's the entire thing squared. And then we're going to square the right hand side as well. So we have the square root of m squared plus 5 inside brackets, and all of that is squared. So m plus 1 squared becomes m plus 1 by m plus 1, which is m squared plus 2m plus 1. And squaring a square root, they just cancel out. So we just bring down the m squared and the plus 5. So m squareds on both sides will cancel out, leaving us with 2m plus 1 is equal to 5. So we're going to bring the 1 over the equal sign, it becomes minus 1, and 5 minus 1 is 4. So we get 2m is equal to 4, and dividing across by 2, we got m equal to 2. So we're asked to find the value of m, we got m is equal to 2.